Welcome to the deep dive.
Glad to be here.
Today, we're cracking open a stack of documentation all about the SKALE network. Think of it as a real deep look inside the machine, guided by, well, the engineer's own blueprints.
That's right. And our mission for this deep dive is really focused. We want to cut through the technical layers presented in this source material and get straight to the heart of what SKALE is trying to achieve.
Okay.
What are the fundamental problems it aims to solve for decentralized apps, dApps, particularly those struggling on Ethereum? How does it actually work, sort of high level? And crucially, what does this architecture mean for you, whether you're a developer thinking about building or maybe just a user interacting with these kinds of applications?
Okay, let's dig into these documents then. Before we get to SKALE's approach, the documentation spends some time laying out the landscape specifically, the challenges dApps and users face on current blockchains, especially Ethereum mainnet. What are the big pain points the source material identifies right out of the gate?
Yeah, the source is pretty clear on this. And honestly, anyone who's used dApps frequently will probably recognize these frustrations. First, there's the user experience.
Right.
They highlight high fees. We all know about gas fees, right?
Yeah.
Coupled with slow transaction speeds,
Yeah.
high latency.
Yeah, the wait times.
Exactly. And then there's the difficulty in moving assets or data seamlessly between different blockchain environments.
Connect
Many of
sensitivities.
the cost and the weight, those are definitely major hurdles for like mass adoption. It's really hard to imagine mainstream apps working like that.
Totally. And the documentation connects us directly to that classic blockchain challenge, the scalability trilemma.
Yes.
That's the idea that it's inherently difficult, maybe impossible, to have top-notch security, true decentralization, and high-speed or scalability all at once. You usually end up having to compromise on one, maybe two.
And they also point to the limitations of what they call monolithic chains. What's that about? Yes, this refers to blockchains, where basically everything happens on a single main chain. The documentation suggests these are inherently limited.
How so?
Well, they often have strict designs, not much room for customization, which makes horizontal scaling difficult, and they often have low block gas limits. That makes running really complex smart contracts, inefficient or just prohibitively expensive sometimes.
Right, you hit a ceiling. Here's where it gets really interesting, I think. Thinking about these barriers, not just as technical issues, but as things that actively prevent decentralized tech from being useful, even enjoyable for everyday people.
Exactly. It's a real barrier.
So if those are the problems laid out in the source, how does SKALE, according to this documentation, propose to actually solve them? What does this architecture offer?
Okay, so the documents describe SKALE as offering a whole set of specific features designed to tackle these exact issues head on.
Yeah.
Maybe the most eye-catching one is the claim of zero gas fees.
Zero gas.
Yeah. On a SKALE chain, the documentation states neither developers nor end users pay gas for transactions in the traditional sense. The network uses something called SF, F-U-E-L, but it's handled, well, very differently than typical gas.
Hold on, zero gas. That sounds almost too good to be true from a user perspective. Does the documentation explain how that economic model actually works without just, shifting the cost somewhere else sneaky?
Well, it ties back into the network structure, which we'll definitely get to, but the core idea presented is that the cost is covered by the developers or the protocols running on their dedicated chains. It's funded via staking rather than per transaction fees hitting the users.
Ah, okay. So a different model.
A fundamentally different economic model for dApp usage, yeah. Beyond that, speed is a huge focus in the docs. They claim instant finality.
Instant finality, meaning?
Basically, once a block is produced, it's final. Done deal.
So no waiting around for confirmations like on Ethereum?
Correct. That's the claim. And high throughput, too. The documentation mentions a baseline of 400 transactions per second per chain, with peaks potentially up to 700 TPS.
Wow, okay. Compare that with, typical TPS on Ethereum mainnet?
It's a different league performance-wise, according to these specs.
Okay, fast and free for the user, that starts to sound much more like the kind of performance you'd need for, mainstream applications. What else is key in their solution?
So to counter those monolithic chain limits we talked about, they highlight a very high block gas limit, 280 million.
280 million, that's huge.
It is. And that's crucial for developers building complex applications. It lets smart contracts execute without hitting those restrictive gas ceilings you find elsewhere. They also emphasize purpose-built chains.
Purpose-built chains.
Right.
What does purpose-built mean in this context? What are they getting at?
So the documentation introduces these concepts of AppChains and HubChains. These are basically customizable, independent chains. It's all about horizontal scaling. Instead of everyone competing for space on one single chain, applications or groups can get their own dedicated or shared environments. Think of it less like one super busy highway and more like having the option to use your own dedicated express lane, or maybe join a smaller, less congested road that's designed for a specific type of traffic.
Okay, having dedicated environments sounds great for performance, but how do these different chains, how do they talk to each other? Or back to Ethereum, for that matter?
Good question. That's where their native bridge comes in.
Right.
The documentation describes it as a fast, secure bridge, allowing transfers between SKALE chains themselves and also back and forth with Ethereum mainnet.
How fast?
They claim finalized transactions between SKALE chains in about 18 seconds. And it's designed to support all the popular token standards, ERC-20, ERC-721 for NFTs, ERC-1155, and even just generic data through a low-level messaging protocol.
Versatile. And I think I saw a native oracle mentioned too.
Yes, exactly. A decentralized built-in oracle. The key thing here, according to the docs, is that reading off-chain data using this oracle doesn't incur transaction costs.
Ah, that's important.
Crucial for many dApps, like games needing scores or DeFi protocols needing price feeds, things that need real-world info frequently. And underpinning all of this is their security model. It's described as decentralized and fault-tolerant.
How does that work?
Each SKALE chain is supported by a group of 16 validator nodes. These nodes are randomly selected and frequently rotated for security, and the system is designed with a Byzantine fault tolerance of 13, meaning it can handle up to a third of those nodes being faulty or malicious.
Okay, 16 nodes, rotated, BFT, got it. And the document talks about it being a hybrid layer 1, layer 2. What's the significance of that? What does hybrid mean here?
Yeah, that's a really fascinating piece of their architecture as described. The documentation explains that while SKALE chains operate with the performance and decentralization characteristics you'd expect from a layer 1, they produce their own blocks, run their own consensus.
Right, like a standalone chain.
Exactly. But they derive a significant part of their security guarantee from Ethereum mainnet. It's kind of like running independently most of the time, but regularly checking in and anchoring their state, their truth, to the most secure, decentralized base layer out there, which is Ethereum.
Interesting. So it gets some security inheritance, but runs fast on its own.
Yeah.
Okay, so that's a really compelling list of solutions laid out in the documentation. But how does the network actually do all this? What's the underlying architecture and technology described? What makes it tick?
Okay, the nuts and bolts. The core mechanism described is that dApp developers essentially lease or subscribe to computing and storage resources. These resources are provided by a network of validator nodes.
Right.
They use these leased resources to run their own isolated, fast, containerized, EVM-compatible blockchains. Those are the SKALE chains we've been talking about.
So wait, a developer isn't just deploying a smart contract onto a shared public chain. They're actually deploying their dApp onto its own chain environment.
Precisely, yes. It's like getting your own dedicated computation space. And these individual SKALE chains interact via that native validator secured bridge we mentioned. They call it IMO, interchain messaging agent. That allows tokens and messages to flow between the SKALE chains and also back to Ethereum.
And the zero-cost transactions happen within these dedicated chains.
Exactly. They run on these dedicated proof-of-stake chains distributed across those random sets of 16 nodes we discussed.
And the documentation mentions supernodes. What role do they play?
Yeah, so decentralized validator organizations, the entities running the hardware, operate what SKALE calls supernodes. These are essentially aggregations of computing power. They provide the distributed resources needed to run all these different SKALE chains.
Okay. And how is this whole thing managed? All these chains, validators, resources?
The entire network, according to the docs, is managed by a system called the SKALE Manager. And here's a key point. The SKALE Manager is a set of over 35 smart contracts that live on the Ethereum mainnet.
Oh, interesting. So Ethereum isn't running the dApps themselves, but it's running the manager of the whole SKALE network.
Exactly. The documentation really highlights this. The SKALE Manager on Ethereum handles all the critical network functions. Things like creating new SKALE chains, registering validators, selecting which validators go into which supernodes, rotating those nodes periodically for security, and also managing the staking, the payments, and any slashing penalties if validators misbehave.
So it leverages Ethereum's security and decentralization for the really critical control plane stuff.
That's the idea presented, using Ethereum as the trust anchor.
And the SKALE token, where does that fit in?
Right, the SKALE token is the native utility token for the network. Validators, and also people who just want to delegate to validators, stake SKL to help secure the network, and in return, they earn rewards. And dApp developers use SKL to subscribe to the computing power and storage they need for the scale chains they want to run.
So it fuels the whole system's security and access.
Pretty much. The source points to a pretty significant validator community, already mentioning over 45 independent operators running over 112 supernodes, which collectively manage 896 individual nodes securing the scale chains. They also boast about the mainnet's solid uptime in the docks, over 300 days without interruption at the time of writing.
Okay, this sounds technologically complex underneath. The documentation lists several specific technologies, cryptographic approaches. Can you maybe walk us through a couple of the most important ones mentioned and how they enable these features, scale claims like the speed and zero gas?
Absolutely. Happy to. They talk quite a bit about pooled validation proof of stake. The core idea here, as described, is that the security of the entire network of scale chains isn't fragmented chain by chain. Instead, it's pooled across all the validators staking SKL on the main Ethereum network.
Okay.
And then each individual scale chain is secured by a random subset of those validators, those 16 nodes. This approach, they argue, allows security to scale horizontally as more chains are added, without needing a massive dedicated validator set for every single chain.
Right, that makes sense. Shared security resources across dedicated chains. Smart. What about the speed and that instant finality claim? How do they achieve that?
For that, the docs point heavily towards threshold cryptography and a specific consensus mechanism they use called asynchronous binary Byzantine agreement, or ABBA consensus.
Okay, let's break those down. Threshold cryptography.
So threshold cryptography basically allows a required number, a threshold, of validators within that group of 16 to collectively sign a message or perform a cryptographic operation without any single validator having to reveal their individual private key.
Ah, okay, security through numbers.
Exactly. The documentation explains this is really key for enabling fast block signing and ensuring data availability across the 16 nodes securing a chain, even if a few are slow or offline.
And the ABBA consensus.
Right, ABBA consensus. This is used within each 16-node group for reaching agreement on transactions. It's described in the source as being leaderless, which is important, no single point of failure.
No bottleneck.
Right. It's also provably fast finality, meaning once agreement is reached, it's final very quickly. And it's Byzantine fault tolerant, handling those potentially faulty nodes we talked about.
Byzantine fault tolerant, that basically means it can still reach the right agreement even if some, up to a third in their case, of the validators are malicious or offline, correct?
Precisely. You got it. And being leaderless means there isn't one specific node in charge of proposing blocks each round, which could slow things down or become a target. So the combination described in the docs, threshold crypto for fast, secure group signing, and ABBA for fast, leaderless, fault-tolerant consensus within these small, randomly assigned groups of 16 validators per chain, that's really the technical engine they claim drives that near-instant finality and high throughput.
It really feels like these specific technical choices are absolutely crucial to delivering on those big headline features like the zero gas and the instant finality.
Very interesting. The documentation also mentions a hybrid container architecture and trusted execution environment, TEs. What are those about? Yes, so the hybrid container architecture relates to how the scale chains are actually run day-to-day by the validators. They operate within these virtualized container environments, sort of like Docker containers, managed by the validator nodes.
Okay.
The documentation says this allows for really agile, isolated, and flexible allocation of compute resources for each individual chain. Keeps them separate and performing well.
And Ts, trusted execution environments.
Yeah, Ps are mentioned as well. These are secure areas within a processor. The documentation suggests they help with things like secure, fast block signing within those containerized environments, and also potentially help validators manage multiple scale chains efficiently and securely on their hardware.
So the containers provide the isolated sandboxes for each chain, and Ts might help secure certain critical processes running inside them.
That seems to be the picture painted by the documentation, yeah. It's definitely a blend of different technical pieces working together. And again, crucially, all of this relies on the underlying security and the decentralized state management provided by those scale manager smart contracts running back on Ethereum mainnet.
Right, always anchoring back to Ethereum. Okay. Now, you mentioned earlier AppChains and HubChains when discussing purpose-built chains. Can we just clarify the distinction there based on what the documentation says? Are they technically different?
Good point to revisit. So the documentation actually notes that structurally, All scale chains are fundamentally identical in their core capabilities. They have the same potential throughput, same storage capacity, same size limits, etc.
Okay.
They also share the same developer experience, apparently. Using that SFUEL for gas, which again is paid at the developer protocol layer, not by the end user, they have permissioned contract deployment, meaning the chain owner controls who can deploy contracts. And they all have that built-in connection back to Ethereum via the IMA bridge.
So technically the same, then what's the difference?
The difference lies purely in their use case and their operation model, according to the source.
Okay, so what's the primary use case described for an app chain?
Well, an app chain, just like the name suggests, is a scale chain that's dedicated entirely to a single application or maybe a single project.
Makes sense.
The documentation says these are ideal for projects that anticipate really high transaction volumes, or maybe applications that require a fully isolated, predictable compute environment where they don't want to share resources. This is where, high-performance game or a big DeFi protocol needing hundreds of transactions per second might choose to live, or maybe enterprises wanting their own specific blockchain infrastructure without sharing.
Got it. Truly dedicated resources for demanding applications. And HubChains, then, how are they different?
HubChains are described as community-operated shared environments. Think of them as multi-tenant chains. The documentation describes them as sort of Web3 service layers, often divided by use case. They mention examples like maybe a gaming hub or an AI hub or a DeFi hub.
So multiple projects sharing one chain.
Exactly. These are designed for perhaps newer projects or projects that might not need the full power of a dedicated chain right away. Or, importantly, for projects that want to easily collaborate and interact with other related projects operating within that same shared hub environment. It offers a potentially lower-cost entry point compared to getting your own dedicated app chain and fosters that ecosystem feel.
Okay, so Scale offers distinct options depending on whether you need your own sort of private highway, the app chain, or if you want to join a shared, bustling city district, the hub chain.
That's a good analogy.
Mm.
Yeah, the documentation presents it as providing flexibility for developers to choose the right kind of environment for their specific needs and scale.
Right. Okay. So for someone listening who finds all this interesting, maybe either as a potential user of dApps who wants faster, cheaper experiences, or perhaps a builder thinking about platforms, how does the documentation suggest they can actually, engage with the Scale network? Where do they go?
Yeah, the documentation provides some clear pointers depending on who you are, essentially. If you're simply looking to experience applications that are already running on Scale, they direct you to what they call the Scale portal.
The Scale portal?
Yeah, that's presented as the main place to discover dApps that are live on the network. The user-facing front door, if you will.
Simple enough for users. What about developers who are listening and thinking, okay, zero gas, instant finality. That sounds compelling. How do I actually build on this thing?
For developers, the documentation points them straight to their quick start guide. That's positioned as the main resource for getting the technical details, the step-by-step on how to deploy your dApp onto a Scale chain. It's where you'd find the practical implementation steps, the code snippets, all that.
Makes sense. Developer docs. And if you just want to stay informed or maybe connect with the broader community around Scale?
They list quite a few community channels in the source material. There's their official blog for articles and updates, a Discord server, and they even highlight specific channels within it for developers and for validators. There's a forum for maybe broader discussions, governance topics, a Telegram group for more casual conversation, their X account, formerly Twitter, for quick updates, and also a YouTube channel that apparently has tutorials and informational videos.
Lots of ways to plug in. So what this all means for you listening, whether you're someone just curious about faster, cheaper dApps, or maybe you're a developer looking for a potentially more scalable platform, it means there are different pathways laid out in the source material to jump in and explore further.
It certainly seems like they're trying to make the information and the various entry points readily available. Yeah.
Okay. Well, this deep dive into the Scale documentation has really, I think, shown us the layers of their proposed solution to some pretty fundamental blockchain problems.
It definitely lays out a detailed picture of their core value proposition, doesn't it? It's all about tackling that scalability trilemma, aiming to bring a significantly improved user experience to Ethereum dApps. And they do that through this unique multi-chain architecture, the zero gas fees, the high performance claims.
Right.
And they're not just, claiming these benefits vaguely. The documentation attempts to show the technical foundation, the pooled validation, the threshold crypto, the ABBA consensus, those containerized chains that they believe makes it all possible.
It's certainly a comprehensive look at their specific approach. This whole discussion, drawing directly from their source material, it raises a really important question for you, the listener, to consider. If we could genuinely remove these major barriers of high costs and slow speeds from decentralized applications,
Hmm.
if we move towards a world that felt like zero gas and instant transactions, how might that fundamentally unlock new use cases? Or maybe accelerate the adoption of blockchain technology in ways we can't even fully imagine today?
Yeah, it's like,
Think about how the internet changed when broadband replaced dial-up, right? Suddenly, streaming video, complex web apps became possible. What's the potential broadband moment for decentralized tech if these friction points disappear?
it really prompts you to think beyond the current limitations
Yeah,
about what becomes truly possible when those everyday friction points are just gone.
a lot to ponder indeed. That's it for this deep dive.